Hello members, we are back in another video. We are still looking at our topic, nuclear processes under chemistry. We said our target is to simplify it. If you didn't watch the previous videos, we made one about the introduction to this topic and one to the introductory part of the radioactivities or decay of different unstable elements. And we so far made videos about alpha decay and beta decay. For now, in this video, I want us to simplify gamma decay. So when we talk of gamma decay, unlike the other two radiations, the alpha and beta, the gamma are not particles. The gamma are actually electromagnetic radiations. And these radiations are defined to have short wavelength. So they are simply electromagnetic radiations. They are rays of electromagnetic radiations, but these electromagnetic radiations having short wavelength. These gamma radiations have no mass number or atomic number. Unlike the gamma unlike the alpha that are positively charged and the beta that are negatively charged, the gamma rays or the gamma radiations carry no charge. So the unstable nuclei undergo decay by emission of gamma rays when they get excited and release energy as gamma radiations. They are usually converted to other nuclei, but these nuclei have the parent nuclei. For example, this one, its atomic number, mass number, and the atomic numbers are not affected. They remain the same, though the nuclei changes to another one. With the emission of gamma rays, we termed as electromagnetic radiations with short wavelength and emission of energy. This form or this kind of conversion or decay or radioactivity, where the atomic number and the mass numbers are not affected, but the parent nuclei has disintegrated to form a new or daughter nuclei without affecting the mass numbers and the atomic numbers. This kind of process is known as transmutation. So transmutation is simply the excitation of unstable nuclei decaying to form or disintegrating to form a stable nuclei without affecting the atomic number and the mass numbers. It's what we shall call transmutation. So as the particle decay by emission of gamma rays and formation of energy, the atomic number and the mass number remain unchanged. These gamma rays have got properties, and some of these properties are as simple as these ones are rays, and the arrays, not particles like the alpha and beta, the arrays of electromagnetic radiations. Remember, we said the alpha particles were helium nuclei, the beta particles were fast moving electrons, and then the gamma radiations are simply rays of electromagnetic radiations. We said the alpha particles were positively charged, the beta particles were negatively charged, the gamma radiations carry no charge. To go on, these ones have the least, they actually have the least ionizing power. Though they have the greatest, penetrating power, that they can even pass through a piece of paper of any thickness. They can pass through aluminium materials of any thickness, and they are only stopped by thick. They are only stopped by thick lead foils or lead plates. So long as the surface is made of lead, it is the only one that can stop gamma rays from passing through. If this is a radiation here, and there are three barriers, this is a radiation. If a radiation is, let's say, containing both alpha, beta, and gamma rays, if this is a piece of paper, the alpha particles will not go through, but the beta and gamma rays will be capable of passing through. To continue, if this is an aluminium foil, the only rays that will be capable of passing through the aluminium foil of these two will be the gamma, because they have the greatest penetrating power compared to the beta ones. So they can only be stopped by lead materials. Let me think we are flowing. These ones cannot be deflected by both electrical and magnetic. None of those fields can deflect the gamma rays. For an explanation on this, If these are the fields, let's say if these are electric fields, and this is a negative plate, positive plate, and this is a mixture of the radiations, the gamma rays will pass through and deflected. So these are gamma rays. The alpha particles will be deflected to the least extent, but the beta ones will be greatly deflected compared to the gamma ones. Compared to the alpha ones. So these are electrical fields. The same applies to magnetic fields. They greatly deflect beta radiations, do not reflect the gamma, but less deflects or bends the alpha radiations. For ionization energy or the ionizing power, the alpha particles will appear as thick visible traces because they can easily ionize through air. The beta ones will appear as irregular thin lines compared to these ones. These ones are straight thick lines. They form thick and straight visible traces. And then these are the alpha in terms of ionizing power in air. These are the beta ones. And then the gamma will appear as invisible traces that are spaced. Very thin dotted points. These are the gamma because they are ionized in the air to the least amount. Though they have the greatest range in air. Let's hope we are moving. To go on, we are giving some of the properties of the gamma radiations. We said they carry no charge. To move on, the gamma radiations move at a speed of light. They are very light radiations. They move at a speed of light. So they are streams of very fast moving electromagnetic radiations. To move on, they cause fluorescence of fluorescent materials. So there are more other properties of these rays, of the gamma rays. But remember we said that as they are emitted, they are only emitted as energy. Yes, the unstable nucleus is turned to a stable one without affecting the mass number and the atomic number by a process known as transmutation. Through that unstable nucleus getting excited. And I think we are flowing. Everyone is speed. To cut the story short, they have the same applications. They have the same applications as the alpha and beta radiations. And we mentioned some of these radiations. We talked of being a source of energy in nuclear plants. The energy emitted during this emission of these particles, the gamma particles, is in form of heat that heats up water, providing steam that runs the turbines. So it is an energy source in nuclear reactors. We can talk of sterilizing medical equipment, using it as a preservative in food. We can talk of used as a tracing radiations in security to detect for weapons and other radioactive weapons made out of radioactive uh, materials. We can talk about all of those applications we talked about, alpha and beta. So if you don't mind, please just allow me. We meet in the next part of nuclear chemistry, which is simply um, nuclear fission and fusion as at the same time half-life. We said I'm online. If you are watching and you're not part of our WhatsApp group for updates, please contact us on that WhatsApp number 0703 27 82 31. 0703 27 82 31. I'm Teacher Alan.